What's going on? Today is the first video of a series of videos I am planning to lay out to cover the Linux Red Hat or the Red Hat Enterprise Linux. So basically, this is the first video of this series, and in this video, I'm going to cover the basics of Linux file system. Now, basically, Red Hat is a company that has developed the distribution called Red Hat Enterprise Linux. And you can just download this distribution by going to Red Hat developers, creating an account, and then going to Linux. In here, you can just click on download RHEL or Red Hat Enterprise Linux so that you can download the distribution. Now, in order for you to follow up with me in the upcoming videos and in this video, you need to download the um, ISO, right? And just create a virtual machine. As you can see here, virtual machine will be your Red Hat Enterprise Linux. Now, there are many training videos on the internet and YouTube to cover the basic steps to install the distribution on your virtual machine. I'm not going to go over that. I'm going to just start right away with the basic concepts, right, and the training that cover this distribution. Now, you can take the material that will be laid out in the current video and in the upcoming videos as training material for your exam, or you can take it as a training material if you are curious enough to work on this distribution. Okay, so let me switch now to my board, and we can start. We're going to start talking about the Linux file system. So before starting out in Red Hat and any Linux distribution, we have first to develop an understanding of what is of the file system structure, the directories, and the hierarchy. So to start with, Linux always operates in a hierarchical form. So basically, first you will find we have first here the root file system, right? And under the root file system, we have subdirectories. So this is called the root file system, which is the highest directory in the structure. Next, under this directory, we have many directories, right? So here, for example, we have the /dev. We're going to explain every one of these back later. Next, we have, for example, the etc. And also, we have home. Also temp. And user. Of course, we have var. And we have many like opt, sys, but this is to start with root. Okay. So we have here the parent directory, which is the root file system. Under this parent directory, we have directories here, right? So basically, so these are the directories, right? And this is the parent directory, which is the root file system. Now, under these directories, we have subdirectories, okay? So the subdirectories, for example, if we take an example here, under dev, right? So under dev, we have two. We have /block. I'm very bad at allocating spaces. And we have PFS. Also, for example, if we take the user, under user, you have bin, sbin, and many others. Now, you can find a similar structure or a similar hierarchy in the internet. You can find a detailed hierarchy of all of the directories, subdirectories, and the files. But the bottom line here is to show you guys that the file system in Linux starts with the top level being the root file system. Okay. Under the root file system, you have the directories, dev, etc, etc. Under the directories, we call them subdirectories. Okay, whatever comes after the directories, we have subdirectories. Okay, or child directories, we can call them. That's the basic structure or terminology of the Linux file system. Now we're going to explain the purpose of every directory in Linux, which is vastly important to understand how to operate on Linux files on Linux distributions. So, for example, let's start with the etc. So, what do we have in etc here? I mean, what is the purpose of the etc directory? So basically, etc directory holds, let's say, system configuration, system configurations, file configs. Also, you can find some subdirectories under etc. For example, under etc, we can find, um, say, systemd. You can also find under etc other subdirectories such as lvm, etc. So what's systemd? Systemd is configuration files for the systemd, technically, right? We can also find other configurations under etc, which we will go over later in details. Now, so basically, it's just enough to say that etc holds system configurations and file configurations. One prominent example is the Apache configuration. So if you run a web server, if you have a web server and the web server is Apache, you will find its configuration under etc, right? So that's the purpose of etc. Next, we have the root. And most of you know that root is the target directory. When you do pen testing, your objective is to get access to that root directory. Why? Because the root is the home directory for what? The root user. That's why this is your objective when you do pen testing, is to get access to that directory. Normally, only the root user have access to this directory. Just to take a note of that. Now, next we have the MNC. So the MNC, it's very self-explanatory to say that MNC is used to mount a file system, right? Temporarily, let's say, mount a file system temporarily. Now, what other vectors we have? So let's put slash here. Also, we have the boot. And most of you know what is the purpose of this directory: to hold boot support configuration, boot files, boot config files. Okay, let's create another page now. Okay, so what else we have? Let's switch the color. So we have the home. And most of you know that home directory is for storing the user contents, such as desktop, documents, videos, pictures, whatever. Next, we have the opt. Now, opt stands for optional. So here it means optional. So what's the purpose of that directory? So technically, you can use opt to hold additional software. So additional packages, additional software, and all of its suffice. You can find that in opt. Okay. Now next we have slash user. So slash user, example is user share, right? User bin, user sbin. So slash user contains or holds system files. Example, One example subdirectory is slash user slash bin. So slash user slash bin holds what? The user executable files or binaries. An example is, what do you think? ls as an example to list files, which is a binary, right? User executable binary. So also we have the user s bin. What's the difference? User s bin, technically the s bin, most of the commands here needs elevated privileges, or here let's say it contains uh, executable binaries, okay, for or that are executed normally or require root privileges. Root privileges. That's the key difference between user bin and user s bin. Okay, next, what do we have? Let's change the color. Okay, let's talk about user slash lib and slash user slash lib64. Probably you have heard about these two. So normally we use user lib and user lib64 to contain shared library routines. Why do we hold? Why do we need these shared library routines? Technically, we need them for what? So we need these for the executables in slash user bin and slash user sbin. So basically, all of the executables in user sbin and user bin, they need shared library routines. These shared library routines, you can find them and install them in lib user slash user lib user slash lib64. Okay, what else? What do you think? We have also change the color. So these are critical to understand and get acquainted with these directories and their purpose. Also, you have user share. User share. What do you think we use user share? So technically, user share contains documentation. So documentations, templates, also config files. But why? I know we can hold these files in another directory, but why we use share? Technically, because these may be shared, maybe, or you can share them with Linux platforms, other Linux platforms. So whatever you find here, okay, you can find them in other Linux distributions or platforms. All right, next, new page. Now we have the var. So var stands for, variable, right? So variable, why? Because the content of its files changes. So basically, it holds changed or changeable. No, I'm not going to call it changeable. Let me call it data that frequently changes. Example is, what is an example? Example is logs. So most of the log files are contained in the var directory. An example subdirectory is slash var slash log slash var slash opt, right? Slash var slash spool. So what's the purpose of these? You see, Slash var slash logs. What does it contain? System log files. Slash opt. Here we say software log files. Software logs what were in slash opt. So whatever you install here in slash opt, right, you will find its logs in slash var slash opt. Slash var slash spool, it's for print jobs. Okay. Also, you may hold your web server data here. Slash var slash www slash html here in slash var. Okay. Now you also have the temp. Now, as you can see, temp, we use temp a lot when we do pen testing for a machine and we would like to upload some reverse shell or some executable binaries that are needed for the process of pen testing. We upload them to temp because temp is used to hold, temporary files. So it's used for temporary files. And by saying temporary files, these files will be deleted after a certain period of time. Normally in Linux, these files are deleted, okay, after 10 days. Deleted after 10 days. If not accessed or modified. Okay, so if you store a file in temp and you won't access it or modify it in 10 days, it will be deleted after that period. All right. Slash dev, the mysterious dev. Now, dev, dev stores, why I'm not reading red. Okay. So dev stores nodes or device nodes. Device nodes for what? For the virtual and physical hardware. So technically, all of the virtual devices and physical devices, the hardware, right, is stored in dev. So basically, store device nodes for the physical, virtual, and physical hardware. And Linux communicates, technically the kernel, Linux kernel communicates with the virtual and physical hardware through these nodes. Dev SDA, Dev SDA1, whatsoever. So that's how Linux communicates with your hardware through the nodes here in slash dev. Okay. Next. What else we have? We have slash proc. So slash proc means used for, or let's say it means process by system. Now, why do we use this directory? So basically, we use the proc to store information about the kernel. So here, info about kernel, also CPU, networks, technically everything. So proc stores information about the current state of the kernel, the current hardware configs, the information about the CPU, memory, disks, partitioning, file systems, whatever. You can find it in proc. Now, another directory we have is the slash run. Now, slash run, data about processes running, the processes running on the system. An example of Run is run slash media. So slash run slash media, as you can see, is used to mount what? To mount DVDs, to mount USBs, any external device. Slash run slash media is used to run these or mount them, these devices. Okay, now let's switch now to the Red Hat distribution and see how we can apply this concept in the command line. Okay, so how do we apply the knowledge gained about the Linux file system in the command line? How do we use that knowledge? Or how do we gain that knowledge using the command line tools? So basically, let me make this bigger. No, I did the opposite actually. Zoom in. Okay. So one command is the tree command. So basically, a tree is a command used to display the files and directories, but in a hierarchical form. So for example, I can get a list of, as you can see by typing tree, you will get the list of the directories and the files, but where in the current working directory. So if you type pwd, you will see the current working directory, which is home Motasim, which is my name. So basically, if I type tree here, I will display all of the subdirectories of this directory, which are these, and the files under them, okay, in a hierarchical format. Now, what are the other options of tree? So if we type tree and say -a, you see here we got now many. Let's go up. So many entries here. Why? Because A shows the hidden files, the hidden directories. Everything that starts with dot means that it is hidden. But the takeaway here is that the tree is used to display the hierarchical form of everything. Now, what if I want to get only the hierarchical form of the current working directory, but only with regards to directories? I don't want to display files. I would type tree -a to display the hidden entries and -t to exclude files from the output. So I would only show the directories and the subdirectories in a hierarchical format. So see, only have the directories and their subdirectories in a hierarchical format. Okay, so we are now in pwd. Let's cd to desktop or no need. Okay, let's see now if we want to display the hierarchical format, okay, of the let's say we will exclude the hidden files. We don't want to see the hidden files. We want to display the files and to see the permissions, okay, print the full path of the files and also display the file sizes. But where? If you want to specify a specific directory you are interested in, you have to specify the full path. So home, I'm interested in desktop. So this command will display all of the files and subdirectories of the desktop, but showing the permissions, alongside showing the permissions, the full path of every file and directory or subdirectory, and the size in a human readable format. See, under Home Motosim Desktop, we have the file demo.txt. As you can see, the full path has been shown, and I have here the file size, which is 5, and on the left I have the permissions. So in the last video, or the previous video, Linux Foundation full course, we talked about the permissions and why they are vitally important in order to proceed with learning Linux. So these are the permissions, and as I was mentioned earlier, this is for the owner, this is for the group, and this is for everyone. Okay, so using the tree command, you can use the tree command to either list files and directories, or if you like to use the hierarchical format to understand more about the file system, you can use the tree command. So let's say I want to understand the hierarchy of the etc directory. So tree, of course, you would want to exclude the files because you want to output to be manageable. So I would exclude the files by typing -d, and I will exclude also the hidden files. I don't want to show the hidden files. So -d to exclude the output, and -p, or sorry, p to show the permissions and the directory. So see here, I displayed all of the subdirectories under etc, but in a hierarchical format, okay, along with the permissions. Now, another option to tree is to use the ls. So ls/etc show me the subdirectories, but I only see them in a list settings or list view. If you want to see them in a hierarchical view, you would use tree command. Or use dash to see the permissions, use -la or long list etc. Now you can view the permissions of the subdirectories and files here. Okay, then that was about the first video of the Linux Red Hat training. In the next video, we're going to talk about basic file management, file operations, compressing, uncompressing, removing, storing, copying, and sim linking or hard linking, whatever. I know we talked about these in the first video, which was the full foundation, but since we are covering a separate distribution, okay, we would just go over them again. So that was it. See you in the next video.